What I'd like to do is to pass over to our first speaker, Teppo Hemia from Wirepas, where he is there the CEO. And he's going to be presenting specifically around the topic of the Internet of Things. Teppo has been in technology and business in executive roles, 20 years of experience of creating, developing and delivering innovative wireless technology products and solutions. He's has experience from several business model creations and turnarounds. I can't believe that everyone has been a success, Teppo, has it? From startup to established business with a $500 million top line. So he's been CEO of Wirepas since 2014. And prior to that, he held various positions at Nokia, ST Microelectronics, ST Ericsson. And with that, I'll pass over to Teppo to perhaps just continue the introduction and flow into his talk. Thank you very much, Teppo.
Thank you, Walter. Thanks for having me, and it's a great pleasure to discuss about this new standard, and especially give the view from Wirepas. Thanks for putting the perspective in the beginning. I thought that I'm already a bit senior guy in the wireless and connectivity, but but as you said, some elements of DECT started a long time ago. So let me start, and I first discuss a little bit about the Wirepas, and actually it has also very long roots. So as long as 20 years ago, the story started in the local university here in Tampere, the same university that did the very first GSM call. So this is a very good place to develop new radio technologies. And at that time, the professors in the university had that vision that there will be a time when there is an endless amount of sensors around us. So when that happens, how on earth, that scale can be built, and how there can be spectrum available for all those different devices to be connected, and also quite importantly, how to make them battery operated, how the power consumption can be got so low that the things can be mobile. Those were extremely good questions and problems to solve, and in fact they came with the first ideas about this fully decentralized autonomous devices, building the networks, forming the networks, optimizing them, maintaining them, and so forth, without any central function. And some years later, Wirepas was then spin off from that university, and Wirepas was focusing on doing a fully IoT systems. Later, 2014, when I also joined, and when we revisit the strategy, we realized that this very valuable core, which is this kind of a decentralized connectivity protocol where we started, is so precious and is so kind of important to get into as many different markets as possible, that it made sense to turn the company to a software company. And so as of today, we don't do any hardware. We are fully focused on software, and we build these systems together with our dear partners, ranging from semiconductor companies to sensor makers, gateway makers, cloud partners, and so forth. And our vision is really to make this kind of a IoT mastery affordable, and it comes with the promise of infinitely scalable connectivity, and in a way that it stays reliable no matter what the scale is. And we focus mainly on industrial applications today. Some of our partners are pushing this also to more consumers, and that's completely fine. But today the scale is really on the industrial side. And we are very proud of being part of this standard creation, and the teams will talk a lot more about the technical details later. But we are also very seriously in this and kind of all in, and then we really look forward to be the first mover and be really leading this going forward. So we are today about 70 people, growing as you can imagine, and quite importantly, we have a growing developer ecosystem and partner ecosystem. So we have about 200 licenses of different sizes around the world, and you can find a few hundreds of products already in a public space in our website, but there is a lot more in the pipe, and that's kind of the company quick background. Then when we move to what this kind of decentralized approach is about, and I want to put some reflections to cellular obviously here, because we want to make the point of how this is different, although it's also called 5G. So as we very well know, the 3GPP ecosystem has invested a lot in this space, and they have narrowband IoT, LTE-M, which are very good for certain purposes that they are designed for, but it doesn't nearly, it doesn't even nearly cover all the opportunities, and we took into this quite different approach. So instead of building that very expensive infrastructure, we took by software all that into the devices and decentralized the whole networking function. And that also gives us possibility to together with our partners to tailor the solution for different needs. So this elasticity is very important, because we are, for example, in smart lighting, which is very different use case than like smart tracking in logistics or smart metering or street lighting. They are all different from the connectivity requirement standpoint. What we are also proud of is that this way of doing things is probably the lowest power possible you can do for massive IoT type of networks, and of course it also brings the sustainability aspect into the market. And if we look kind of a little bit more through engineer lens here, so we have the typical cellular architecture for broadband use, and it's obviously one of the biggest, if not the biggest, engineering work in the whole wide world, and we all enjoy it very much. And it's a huge business. It's a 1 trillion business as a cumulative service around the world, which is operated regionally and has licensed band regionally. Well, that structure is not necessarily the right one then going for the high-scale massive IoT. So massive IoT doesn't necessarily give a return for that type of infrastructure that the cellular has used to play. So the ARPU for consumers with the mobile phones and so forth it's a much bigger business than what the kind of a large scale IoT devices can handle. So with this non-cellular 5G, the big benefit is that all that CapEx can be reused, whether it's Wi-Fi backhaul or cellular backhaul or Ethernet or fiber, it's totally agnostic, and that gives a huge saving in the deployments. But also that we as a company offer these networks without any data fees or monthly subscriptions. It's a one-time royalty per device when taken into use, and it means that the data is free forever with those devices. So the OpEx part is also remarkably different than in a typical mobile operator service. And this combination disrupts the market and can build the scale that is not economically possible with the cellular way of doing. And now with this very unique way of doing this meshing in a fully decentralized manner that I'm sure our colleagues, Jussi, Christian, and others will talk more later today how it is done in detail. But that gives the lowest power, very high density, very high spectrum efficiency, And when that is run on a free-to-operate global band, it's very powerful value proposition altogether. Because the higher the density, the better the spectrum efficiency. So you don't really run out of spectrum with this architecture. And Wirepas as a company offers a bit more broadly than what the standard is. So as you may well know, we were the main contributor to the standard, and especially from layer 2 and above, we brought this meshing architecture and principles into the standard. And we started with commodity low-cost Bluetooth chips as a physical layer, and we still do, and they are actually very important also going forward. But it's the same system that now runs on this more advanced OFDM HARC type of radio that we are together with Nordic bringing in the first product launch later this year. And we also have a sub-gigahertz option especially for smart metering, and it has a very high market opportunity, especially countries like India. Now, these options are important so that we can move in the power, kind of a range, reliability, cost axis of different needs in the different markets. But from our point of view, as a Wirepas, as a software offering, is that it's the same software, it's the same stack on the kind of chipsets, and it's the same software as a system. And on the system level, we offer not only the protocol, but services like, or let's say the assets which enable our customers to build services like provisioning, remote over-the-air updates, positioning, security, monitoring. So you don't need any network management system as such, but you obviously want to know what's going on, and full diagnostic is able to be taken from the network. And also we have open source gateway software and backend software. And you can also see more of documentation and technical details in our developer portal. Quite important here is that these assets can be run in cloud or on premise. So that also gives elasticity. Quite many customers of ours don't want to push the data to the cloud or even through the mobile operator. So you have a full freedom to keep the data in your premises. And how this plays against the other technologies, which certainly have their own place and where they are designed for. But if we put them into this chart in terms of cost and in terms of qualities for massive IoT, like scale, density, coverage, we can see that cellular technologies go to the bottom for the simple reason that they are typically offered with data subscription plans. And if you look the lifetime cost in the IoT use cases, it becomes quite expensive. You may have them also in a private use, but you still need to license the spectrum, and the hardware is typically quite complex, starting from the chipset itself. Then on the left top corner, you have this smart home play where Bluetooth mesh chickadees were born, which are quite okay for low scale applications, some tens of nodes. But when you really push for the scale, reliability, coverage, then the architecture of what the DECT 2020 NR represents, then you move the qualities to the top right corner. So actually what we did as a company first was to take the Bluetooth commodity chip and move it to an industrial grade large scale network. And then what we are doing together with all people here is then that we together with Nordic are moving kind of originally for cellular use design chipsets to a place which is much more affordable. And we feel that this domain is very strongly occupied now with these options, and we look forward to have the ability to offer synergy to our customers with one software integration and with different radio configurations. So that's kind of a bit on the positioning market and so forth. I come back a little bit to the market in the end, but now I go through rather quickly some of the areas where we are today and where this new standard can play. So I start with smart tracking, where one of our customers is Prologis, which is the world's biggest real estate warehouse owner, so especially in logistics. And 5,000 warehouses with 100 million square meters. When this type of customer wants to deploy something, there's a lot of systematic repetition around the world, and there is a need which varies from monitoring the real estate itself, but also how to run, for example, lighting, energy saving, but also as they are focusing on logistics, they are able to then offer services to their tenants going forward, like asset tracking and goods in, goods out type of functions. And now the big benefit of this architecture is that with one system you can actually go and serve quite different use cases successfully. And the deployments have all been started in a few thousands of these warehouses. Then an area which has been under preparation for now few let's say a couple of years, and you start to see these coming launched right now, is smart pallet space, and it ranges from this type of a bigger pallets, but also kind of a replaceable plastic packages, which are, for example, for food chain, fresh food, and that sort of applications. And the big challenge in this, when you want to make reverse logistics for the pallets, so kind of a circular round there, is the service centers where the densities can be very, very high. And there's no other radio that can really make that density in a reliable manner. And what we are also enabling is inventory per pallet, where thousands of objects can be in the pallet, and we can run inventory within a minute with 100% accuracy. Orange Business Services is an example of indoor positioning asset tracking, where one of the benefits is that the anchor nodes can be battery operated, the ones that are the reference points for the positioning, and that helps a lot the installation cost and deployment. So this can be quite easily and quickly deployed in any type of context. Few examples on the smart building side. Clevertronics has been out there in the market for some time with us and with great success. Examples like this arena in Sydney, where thousands of emergency lights, exit lights type of fixtures need to be connected, is a good example where again easy installation and reliability is a high value, and independency of other networks. We have here Fagerhult, which is specialized especially on, they are by the way, I think third biggest lighting company in Europe, and here they are focusing especially on the occupancy analytics. So lighting associated with sensoring can give heat maps into different buildings, whether they are shopping malls, offices, and so forth, and especially in a hybrid era, we see a lot of value for the occupancy data to be used for the cost saving, but also planning the spaces and so forth. Also, Sony used the system of Fagerhult, and Haltian in Finland is a very good one. Also, they call Empathic Building is their product name. But here again, what repeats in every example is the high density of devices. Smart factory side, here is the world's biggest pump maker, Sulzer, and this is again a different harsh environment to put vibration sensors to the motors to have the condition information and also predict the failures. And here we have a local partner, Trion from Tampere, who has been part of the project building these industrial nodes. And then we have the biggest ball bearing company, Schaeffler, who has actually quite broad portfolio already by now. So it consists of these very clever industrial sensors for the same job that Sulzer is doing. So monitoring the ball bearing. So anything that moves or rotates in the factory requires ball bearing, and these are enabling to put kind of a sensor to each of them. So previously people were putting like 5% of the motors connected. Now it's no-brainer to connect them all. And they also having not only the sensors, but also lubrication devices are also connected and automated. Very much my favorite application, connecting helmets. Again, no infrastructure in a new construction site, so it's easy to bring with the helmet and with the kind of a fixed node that you put on the walls, and you create positioning information into the building. And one more on this category, Coulon is leading a mining company in Australia, and everybody can understand that there's no networks in mines unless you bring them into the places, and they are doing it in a clever way mostly by lighting, but also other methods. And they also collaborating with, for example, the Wake Up to connect the people as well. And my last example is coming from smart metering area, or last category. This example is the city of Oslo, where about 1 million meters are in a single mesh. So it's a single monolithic mesh that has been running there now for a couple of years with excellent KPIs. So first of all, the installation is very simple and smooth, because you don't need to make radio planning, you don't need to build rooftop antennas, or you don't need to build repeaters or so, because you have 1 million base stations with the 1 million meters. And if each are ranging kilometers, it's a very high coverage naturally by the meters alone. At the same time, you need to be able to cover high densities in the basements of apartment houses. And the SLAs have been 3 to 4 nines constantly, and you can run over the updates. And here the backhaul is cellular, which is with the ratio of 1 to 300 of those meters. So 1 in 300, you have a cellular backhaul. But nice thing is that if you lose that meter with the cellular backhaul, the nodes that were connected to that gateway can actually reroute and rebalance the load to the remaining. So this is kind of close to impossible to break this network. And my very last example is very fast growing, huge business, is the meter rollout in India, where only 5% of the total 250 million is already connected. We are already about 50 in all the deployments, 50%. And here all the qualities of affordability, reliability, good latency, and so forth are spot on value for emerging countries. Also for Wirepas as a company, this is great opportunity, because our business model is to license the software to the local players. We are enabling number of AMI solution providers who can then make most affordable and local service in India. And here our target is not less, but to have half of the market in India with this technology. And then coming back to the market a little bit, like I said, so this is from Ericsson Mobility Report, and I see similar numbers from other analysts as well. the MMTC corner of 5G is still lower than the rest of the cellular, obviously, but the growth rate is very different. And already by 27, it's bypassing the mobile broadband altogether. And this means that with 2.8 billion connections by 27, the annual new devices will be in the range of 1 billion. If we take all the low power wide area networks into the math, it's almost 2 billion. So this is really the area where we see a good part of non-cellular 5G being a great alternative. And we as a company, with those other configurations, we address beyond that as well for even lower cost. But my important kind of a view here, or message that I want to pass, is that we as a company, we have no need to have these 3 different configurations. I think if the standard can grow to a direction where also the lowest cost options can be enabled, there's really no limit where this can be used, because the affordability drives the addressable market. And you can see from those different examples that there's really not good understanding where the limit is. For example, we have a project ongoing to connect BICs. So there are billion BICs. So livestock can be a great example. There's a lot of verticals that we have proven, about 100 of them, and we see this now working well. But I'm really looking forward that these technology cost points are getting also to a place where the growth can be even stronger. So this was my part, and happy to have a few questions if you have.
Excellent. Thank you very much, Teppo. And perhaps whilst people are putting some questions on the chat, I can just offer a couple of thoughts or questions myself. But I would encourage you to put some questions on the chat, please, because I can't fill all the gaps. I was particularly impressed with the length of time that Wirepas has been around, and the scale of some of those deployments that you were describing there, Teppo. What is it about DECT NR+ then that is so different and so important going forward? You know, what is it that it delivers that perhaps you're using other wireless technologies already? What is so different with DECT?
Well, that especially brings the kind of a combination and let's say elasticity where you can play with different ranges, because this automatic output power adjustment is a great feature in the standard, that if you have a dense installation in the campus or in the building, it's very, very low power. But at the same time, you can reach nodes that are kilometers away. And that's something that kind of no other technology offers as a elasticity, if you like. And then I think this is the first time that mesh technologies, and of course we believe this is unique from the scalability point of view, but even among all the mesh technologies, this is now having the most modern physical layer. So OFDM HARC as a combination gives really outstanding reliability. So mesh brings this redundancy in the routing level, which is already great in the other radios that we are using. But now with this physical layer, it really takes to a level that you can replace wires in factories and different places, and that's a big sustainability value as well.
So it's very much the technical capability rather than purely simply a cost factor.
Well, in the beginning, the cost is not as good as with some other radios we are using, but it will be there when the ecosystem grows and we have dedicated optimized chipsets for this standard. We are very pleased and happy to work with Nordic, and that they have the silicon to start with, and that's super good and great. And I can tell there's already a lot of traction and interest with that. But we need to wait a little bit to get that kind of a little bit lower. Of course, I cannot miss the point of the spectrum. There are, I mean, that's something that is front of us going forward, that it gets more and more crowded. And now with this architecture where the spectrum efficiency improves when density goes high, it really give a long use for the scarce spectrum availability. But it's also for some use cases. For example, in automotive, we know some customers who by category just doesn't allow any 2.4 gigahertz radios to enter to the factory. And then it might be the only way to offer something for IoT, because in IoT, there's no easy solution even with private networks. The 5G mobile broadband with private network and leasing band, and for example 3.5 gigahertz and so forth. But for large scale sensoring, there's no good other option. So this is much welcomed as a kind of a free to operate dedicated band for this purpose that allows to go for any scale.
Okay, that's a good comprehensive answer there, Teppo. We've got a couple of other questions that have come through, so let's just move on to those. You mentioned the phrase reliability. Someone has asked, how is the communication reliability evaluated, particularly for real-world deployments where bands are shared with other protocols?
Yeah, so actually, with these Bluetooth chips that we are using, by the way, when we use Bluetooth, we just use the silicon. We replace the stack with our stack, which is then the same that is contributed here as a standard. So we all understand that is operating 2.4 gigahertz, which is super crowded. And the reliability is really demonstrated in real environments where there's a lot of Wi-Fi traffic, and this frequency agility is the answer. So every link in the network can locally optimize. The peers can negotiate at what frequency, at what time they are using. So given that not all the channels are completely jammed, which is very rarely the case, this is not only reliable in that crowded environment, but it's also the most polite to other radios. And we have also measures and test reports from together with universities where we have tested in a crowded Wi-Fi environment where this is degrading the Wi-Fi performance very, very minimal. So that's also very important, that the IT departments doesn't need to negotiate the channel allocations of Wi-Fi's and IoT networks. It's all automatic by design and comes with the device autonomy. Yeah.
So I think to answer the question of how is the reliability evaluated rather than facilitated, I think the answer you gave there was that the reliability has been calculated from simulations of the systems.
Yeah, I think Jussi can answer better to that later today, but of course it was part of the independent evaluation group evaluations of the 5G process, where it was proven that the reliability is very high. But it comes from this fact that the devices can negotiate with their neighbors and neighbors' neighbors the frequency and time domain parameters, so that they don't collide to each other and they don't collide with other networks. This coexistence is a built-in, which is a very big reliability value.
I mean, in that respect, actually, that's very much part of the heritage that comes with DECT, in that having the time frequency slot, dynamic channel selection you had right with the original DECT thing. It was that was the philosophy that was adopted there. One further question, and again, I think maybe this is again related to spectrum. What is the strategy for spectrum sharing with incumbent technology? Does the system use any version of policy-based spectrum management? And I think this is really perhaps a different take on the same question.
Yeah, so basically the way it works in this shared spectrum, or this, for example, this 1.9 gigahertz, which is this DECT specific ban is that this job is given to the devices itself when they are part of the networks, and you can think it from that point of view that when you allocate spectrum from a cellular way or star topology way, you need to really give a kind of a certain frequencies for quite large areas for single use. Here they can coexist and share the spectrum with quite fine granular TDMA, FDDMA scheme that the devices operate by themselves. And why that is important is that you can have different independent networks in the same spectrum. So you don't need to have a global alignment anywhere. They actually at the end device level take care of it. They do understand because of standard is defined so that they do understand the choices of their neighbors, and they don't go to the same frequency time resource, if you like, same time.
Yeah, there's a lot of intelligence built there into that standard.
Yeah, and I want to highlight that this is one of the rare standards which is based on years of field expertise. So
yeah, that's true. Speaking of field expertise, the other question we've had is how it compares with some of the LoRa mesh initiatives, such as Mesh Plus. The question set goes on to say you took a clear option of contributing decisively to standardizing NR+. What was this key to your strategy to make the technology come mainstream?
Absolutely. I mean, if I answer to that first, so I mean, we are a team that has been around, all the cellular generations. Some of them has been Wi-Fi standardization, or even from the original BLE team of Nokia Research that invented the BLE. So we know that the only way to scale this and make this a mainstream is to standardize and open it. It was in our roadmap all the time. But I need to admit that we were looking the best options for a while, and I think now this opportunity with DECT was probably one of the best options that we could have think of. Because it combines the spectrum availability, it combines the path to 5G and IMT, approval, which also allows all the other frequencies to be used. So this is actually quite powerful specification, which can be used for many purposes. About the LoRa meshing, what needs
just quickly, because we need to move on to Simon now. So just very quickly.
Yeah, the LoRa meshing, if I'm quick, meshing shouldn't be applied for very, very, very narrowband links, because then it's very, 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 very narrowband after that.
Okay, well, thank you very much, Teppo, for that encompassing introduction.